So hey guys, welcome back to Spider-Man's Lab. This is your host Spider-Man6160, and today we are going to study star to delta conversion in the chapter DC circuits in the subject basic electrical engineering. So for this thing to work, we must already know the relationship between delta to star conversion, which I have already written here, and we start from here itself. So what do we do here is we multiply equation 1, then multiply equation 1 with 2, then add it with 2 times 3 and add it with 3 times 1, which gives us 1 times 2, which would give us a b c square, and 2 times 3 would give us a square b c, and 1 times 3 would give us a b square c. Now everyone has a common denominator, which is just the square of a plus b plus c. Notice that these resistance have value a, b and c, as these points are a, b and c. Since it would take a lot of space to write R subscript a, that's why I have just written here a. So R1 plus R2 plus R2 R3 plus R1 R3 gives us, we take the ABC common, a b c, and it leaves us with c square plus a square plus b square, which is nothing but c, a and b, which is nothing but a plus b plus c divided by a plus b plus c the whole square. We can cancel the terms and it leaves us with a b c divided by a plus b plus c. Let's take it to here. This is equal to a b c divided by a plus b plus c. Now notice that bc plus upon this entire term is nothing but r1. So let me erase this first. So R1, R2 plus R2, R3 plus R1, R3 is nothing but A, R1. So similarly, therefore A is equal to R1, R2 plus R2, R3 plus R1, R3 divided by R1. Similarly, we get B is equal to R1, R2 plus R2, R3 plus R1, R3 divided by R2, and C is equal to R1, R2 plus R2, R3 plus R1, R3 divided by R3. So this is how we get the equations. Now the trick here is that to get this value, you look at this point, exactly the opposite, and look which branch is connected directly to it. And in the numerator is this constant, this combination of these, this and this, divided by the branch that is directly connected to the A point. So that's how we get resistance of A. Similarly for B, the combination of this and this divided by the branch which is directly connected to the B, opposite to B, this, and we get R2 divided by R2. And similarly C, combination of this and this divided by the branch that is directly connected to the C, which is opposite to this resistance, and that is R3. So let us take a look at it with the help of a question. So in this question, we need to find the current flowing through this entire circuit. So as we can see here, this 5, 10 and 10 are in a delta configuration. So let's convert it into a star configuration. Let's take a look at. And so to get this one, we must look at this and look at this. So this is A, this is B, this is C. A right here, we get 5 into 10 plus 10 into 10 plus 5 into 10 divided by 5. So we wanted this one, we got the opposite one, and then combination of all. So that would be 200 by 5, which would give us 40 ohms. Similarly, B would be 200 by 10, which would be B opposite 10, so which would be 20 ohms, and that is also equal to C. So what would be our new circuit? Right here. So we know this entire, okay, I forgot. This one was opposite, this is 20, this is 40, and this is 20. Okay, yeah. So we got one here. Then there's a one resistance between this and this. So we got to make it parallel to this. This one's 20 ohms. Never forget to write the unit in the diagram. This is 15 ohms, this is 5 ohms. Now this one is 40 ohms, this one's 20 ohms. So now as you can see here, this is a parallel, this is a parallel, and this right here is just now Wheatstone bridge, and this is a delta, but let's convert it into star. So So let's first calculate this. That would be this would be 4 ohms. Now this one would be 10.90909, 10.90909 ohms. And so now we've got to calculate this one, which I'm directly calculating. This one is 1434. 6 times 8 by 34. 6 times 8 by 34. That is 1.41. This is 6 times 8 by 34, which is 1.41176 ohms. This is 6 times 20 by 34, which is 3.52941 ohms. And this one right here is 8 times 20 by 34, and that would be 4.705 70588 ohms. So now let's convert. Sorry. This is 1.41176 ohms. This is 7.52941 ohms, and this right here is 10.90909 plus 4.70588. That would be 15.61497 ohms. So now we've got to just do the parallel. 15.61497 times 7.52941 divided by 15.61497 plus 7.52941. Now that is just equal to 0.411676 ohms, 5.0792 ohms, 100 volt. And now last one point. Okay. So that would lead us to I equals 100 by 1.41176 plus 5.07992, which would be equal to 100 by 1.41176 plus 5.0799. That would be equal to 15.40438 amps, and that would be in clockwise direction. That is what we get here, and if we match it right here, we've got a long explanation. 15.41 amps.